Assalamualaikum and good day to all. So today I will continue the lecture. So the lecture for the control engineering 2. So before that I would like to let you know that in this lecture it will be divided into two parts. The first part I will show the concept, and the second part I will show the simulation. The purpose of this lecture is to prepare you all for lab. Okay, so it means that we'll divide it into two parts. Firstly, to develop the concept, the fundamental for lab, and then the second part will to I will show you on how to run the simulation. Okay, so before that I would like to explain to you that for the simulation you required to have MATLAB, and then inside the MATLAB we will use Simulink. Okay, so this is the thing. Alright, so next, so this is what we need to cover for the first part 1, and this is for the part 2. Okay, so we go to the second page. So far what we have what we have covered in the topic, that you have the RLC circuit, RLC circuit, okay, and you also have somehow the spring mass damper. This is FT. Then you have the damper, okay, and then after that you convert to the differential equation, and after that you construct the state space equation. So this is what we already had and check. Okay, so now the next step should be have analysis. Is it? So that's why we the first part of the lecture and second part of the lecture will focus on the analysis part. So how we can do the analysis? So the analysis you can first based on the simulation, then with the calculation. Okay, so in this lecture I will focus on the simulation first. Okay, next. So according to the lecture slide, from the lecture slide of mechanical to state space. So if you look at the example that you have the spring mass damper, and then you have FT, and then you have the XDF, and then you have K value, and then you have the FP value, right? Okay, based on that example, we already convert the system to the state space. So the state space of the system is x1, x2 equal to equal to 0, 1, negative k over n, negative fv over n, x1, x2 plus v, 0, 1 over n, ft, and then our output here is equal to 1, 0, Okay, so now what we need to do firstly, our target for the first part 1 of the lecture, we need to develop the signal flow. So in the future, later I will use SFG as the short form for the signal flow graph. Okay, so how we want to develop the signal flow graph from the state space, because we need the signal flow graph in order to convert the system to simulation. That's the use of one of the use of the signal flow graph. So firstly, what you need to do, first you write down all the equations here, okay, in the equation form. X1 dot equal to x2. Based on this one, x1 dot equal to x2 only. Then x2 dot here equal to negative k over m x1 minus fb over m x2 plus with 1 over m ft is a big k over m x1 minus fb over m x2 plus with 1 over m ft. Okay, and then our output here is only x1, right? So y x1. Okay, so we have the information, the important information in here. So next, so I write it down again in here. So better, so easy to refer this one into s2 dot equal to k over m x1 minus f divided by m x2 plus with 1 over m and y equal to x. Okay, so in order for you to draw the signal flow graph, so you need to start with the input u, and the signal flow graph must be n by the y. Refer to the input and y. Next, what you need to do, since this is the second order of the system, so you need to have, show you, okay, if the system is second order, you need to have 1 over s, 2 of 1 over s. So this is the first 1 over s, and this is the second 1 over s. So it means that if your system third order, so you must have 3 of 1 over s. Easy. Okay, so this is second order system, so it means that you must have 1 over s. I will explain to you what is the meaning of the 1 over s, okay, later. Done. And then after that, first you need to label u and y, and then secondly you need to put 1 over s to the signal flow graph. Since this is second order system, so you need to have 2 of 1 over s. The next, you need to write down the x, okay, x, yeah. Okay, what I want to show you that you must starting to write your x from right to left. So we start from x1, x2, x3, x4, x5, and so on. So it means that we need to start from small to big. Okay, so in this case we need to refer to the 1 over s point there, x1, and here should be x2. And however, we don't have any x3 in here, so we just stop until x2 only. Okay, so what is the function of the 1 over s? 1 over s is the integrator. Okay, so it means that in this case you should be have x1 dot. Okay, so you can see that if 1 over s integrator is something like this, 1 over s also equal to integrator x1 dot, then you become x1, so it means that x1 equal to integration of x1 dot. So this is the meaning of this signal flow graph. So you need to integrate the x1 dot and then you will get x1. So for sure in this case it should be x2 dot, right? Okay, done. So this is the base, the structure you must develop first. Okay, next, what you need to do, we need to refer to this equation. The first equation, that x1 dot equal to x2. So x1 dot equal to x2, same thing. So we just write down 1. So this is the meaning of x1 dot equal to x2. Okay, same thing, because we know that x1 dot is 2 because the gain is 1, so it means that refer to this equation here. Okay, next, x2 dot equal to this thing, x2 dot, this is the location of x2 dot. Okay, this is the location of x2 dot, so it must be the construction of negative k over m x1. So this is x1 here, and then must go there to x2 dot. The gain is negative k over m. Okay, because the gain here is negative k over m. Next, x2. So this is the location of x2. So must go to the x2 dot. The gain is negative fv over m. Easy, right? And then after that, the x2 dot also here is combination of plus with 1 over m ft. Since our input here is ft, same thing, because this thing, so here we go there, go to the x2 dot with the gain of 1 over m. Done. Okay, finally we go to the third equation that we need to construct, y equal to x1. So this is your y only equal to x1, so this is your x1. So finally this is your signal flow graph. So what I can conclude again, what I can redraw again to form better features, I will put the equation again, x1 dot equal to x2, x2 dot equal to negative k over m x1 minus fv m x2 plus v1 over m ft, and y equal to x1, is it? And then firstly you need to construct the input and output location y and u. Since this is second order system, so you should have 2 1 over s, go there 1 over s, 1 over s. So the direction must be from input, the direction of your signal flow graph must be from the input to the output. Okay, and then after that, so this is your x1, this is your x1 dot, this is x2 dot. Okay, and then from the equation we know that x1 dot equal to x2, this is referred to this one, and then this is for the first equation. For the second equation, x2 dot here, x2 dot here is negative k over m, okay, of x1, and then negative fv over m of the x2, okay, and then with the 1 over m of the ut input. Ft refer to input, alright. And then after that we have the third equation, y equal to x1. Okay, so easy for the signal program, inshallah. Alright, so later on for the second part, I will teach you how to convert this signal flow graph to MATLAB Simulink. Okay, so see you in a minute.